Hey everybody, here is the next lesson of our Unit 5. This is covering a review of exponent rules. So all the exponent rules we're covering today have been covered with you before in Algebra 1. They are covered on the STAR test. On the STAR test, they do give you all of this information here, the situation and the rules that look like this on your little reference sheet. You are not, however, going to get this reference sheet for any SAT, TSI, or ACT. So you are going to have to know how to use these rules off the top of your head without being able to look at the rules later on. Just a heads up for that. Up at the top here, it says this lesson covers a review of Algebra 1's laws of exponents. These do not always have radicals in them, but are related to radicals in that if you have a fractional exponent, that is actually a radical. It can also be written as a radical. You'll see that at the bottom, that very bottom one down here. Reviewing this information will help us moving forward to simplify and solve radicals. And here we go. So we have all of our rules here with their names, the actual rule typed here, and then two examples. I'm going to go through one column of examples, and then I want you to pause and try the other column of examples. Looking at our first rule, it is called the product rule. It means if everything has its own base, here are bases and here are the exponents. Then if it's the same base, you can just add the exponents together to tell you how many you have total that are being multiplied. So for this first one, I have 4 to the 4th power times 4 to the 1st power. That's the same thing as saying 4 to the power of 5. And the way I got that 5 was 4 plus 1. If it is a smaller number, yes, feel free to actually write down the answer if it's just numbers, not variables. But 4 to the power of 5 is a big number, so I'm not going to try to figure it out. Next is quotient rule. Quotient means divide. You can see here, we each have our own base with our own exponent. When you have bases that are being divided, you just subtract the exponents. Here it shows you're always going to subtract towards the top. I prefer to always subtract towards the larger exponent. Subtract towards the bigger exponent. And the reason we're doing that is because if you always subtract towards the bigger one, kind of how we always move the smaller variable when we're doing equations, you're always going to end up with the positive exponent, so you don't have to then do the negative exponent rule as well. So going through this one, the bigger one's up at the top, so I'm going to put a little arrow there, and I'm going to subtract towards the top. That means in the top, I have 5 cubed minus squared. 3 minus 2 is 1. 5 to the power of 1, same thing as 5. Anytime you don't have an exponent, it's really a 1. We just don't write it down. Good. Next, we have power of a power, or the power rule. That is when we don't have a base for everybody. We have a floating exponent. When you have a floating exponent, it's very similar to distribution in equations. You just multiply that exponent times everything on the inside. So we would have 9 squared to the power of 9. It would be the same thing as saying 9 to the power of 2 times 9, which is 18. That is a very large number, so we're going to leave it like that. Next is the negative exponent rule. The negative exponent rule says that if you move your exponent to the other part of the fraction, it will become positive. So if your exponent is in the numerator and you move it to the denominator, it'll become positive. If it's in the denominator and you move it to the numerator, it'll become positive. You are not flipping the fraction over. You are only moving what has a negative exponent. So let's look at this here. This 2 already exists here. I'm not going to move that 2. Doesn't have a negative exponent. I do have a negative exponent down here in the denominator, so I move it up to the numerator, it'll become positive. So it'll become like this. That's our new numerator. Technically, obviously, we have a denominator of 1 because there's nothing else down there, but we would just leave it like this. Remember, if you have no denominator, you are in the numerator, and your denominator is equal to 1. Because everything can always be divided by 1, it doesn't actually change anything. Same how everything can always be multiplied by 1, but doesn't actually change anything. Next, we have the 0 exponent, which is the easiest one. Anything to the power of 0 is 1, because you don't have any of them. Right? 23 to the power of 0 is 1, because you don't have any 23s multiplied. That's why it says 0. And everything is always multiplying by 1. That's where that 1 really comes from, because everything is always multiplied by 1. We just don't have to write it down. Next is power of a quotient. So power, remember, that means we have a floating exponent. Quotient means we're dividing. So we have a floating exponent and we're dividing, which means I would just give everything inside those parentheses in the top and the bottom my new exponent. And this one we can simplify because it's small enough, it would become 4/25. And the very last one we have here, radical to exponent. This is showing you how you flip back and forth. The benefit to doing this is being able to simplify things. That says here, here's my index. Give you the words we need here. Remember, this is my radical, and then whatever's on the inside is called a radicand. The way I like to remember it is that my radicand stays the same, right? This stays together. We just divide it by what's on the outside. So really it goes like this, like that. Let's look at this one. On the inside, I don't have an exponent, so really it's a 1. And I'm just going to divide it by my exponent on the outside. So it becomes 2 to the 1/4. And then obviously from here you'd simplify if you could, but there's nothing to simplify, so just stays like that. And there you go. Hopefully this review is helpful. Go ahead and pause, try the right column, and then come back when you're ready to check it. Here is our right column. Go ahead and check your answers. I'm going to zoom into half at a time. So here's that top half. The one I think might have been trouble, I'm assuming you're fine on these two, would be this one. Remember, when we're trying to subtract or really divide, quotient rule, we're going to go towards the bigger number so we don't end up with a negative exponent. So that means I'm going to go towards the bottom. Everything is always being multiplied by a 1. If you wanted to put a 1 in front of every variable you've ever seen, you could. There is really a 1 there. We just don't ever write it down. You could also say that every number you're doing is multiplied by a 1 because it doesn't change the value of anything. So this 1 came from right there. And then we have 8 minus 4, which is 4. Here we go. Moving to the bottom half here. Now, for the negative exponent, we were in the numerator. I know I'm in the numerator because I wasn't in the denominator. If there is no denominator, you have to be in the numerator. That wouldn't make sense the other way around, right? And if you don't have a denominator, your denominator is 1. So what I did here was just draw my denominator so you could see it. This was a negative exponent on the top. So if we move it to the bottom, it becomes a positive exponent. And we didn't just flip it over. This 1 was already here from being multiplied by 8 because everything is always being multiplied by 1. Next one is pretty easy. Anything with the power of 0 is 1. Next one down here, we have quotient power. We just multiply everything by a power of 3. And then the bottom one here, this one, just in case you forgot, if there is no number on the outside, so if there's no index number, that's that number out here, then the index number is 2. It is a established assumption that if there is no index, the index is 2. Kind of how we know that if there is no variable or exponent, sorry, the exponent is 1. So we have our 2 here, I drew it there so you could see. And then remember to do that. We keep these together and then just divide by the number on the outside. So this is this. And then we just divide it by that 2. 2 divided by 2 is 1. So this is what we have here. And then anything that doesn't have an exponent has an exponent of 1. We don't have to write it down. So I simplified to that. And there we go. Good. Hopefully this is a good solid review for you. What we did in classes, we did 4 at a time. So go ahead and pause, do 1 through 4, and then come back. If you're stuck on 3, I'll go over 3 fully. So try 3, but if you don't get 3, that's okay. Is 1 through 4. On number 1, I did go ahead and multiply out that f cubed, that 3 to the power of 5, not even close, to give us 243, because I felt like it was small enough to write it down. So we got there by distributing out this 5 per the power rule. Here we have the quotient rule. Oh my gosh, there we go. There. I moved my t's up to the top because that's where the bigger exponent was. So I ended up having t to the 3 minus 1, which is 2. And then I just went ahead and simplified these numbers in the front because I could. And that gets me 2t squared over 5y. Number 4, I'm going to go there next, was pretty simple. We just distributed out our 0. So it was p to the power of 10 times 0, which is just 0. Anything to the power of 0 is 1. And then this one, there we go. This is a good example of how moving to a radical can help you simplify. You might not know what 25 to the power of 1/2 is off the top of your head, But if you were to revert back to a radical, that would actually give you the square root of 25 to the first power, which you could also write like this. And 25 is a perfect square. The square root of 25 is 5. Perfect. Let's go to the next page. Go ahead and do 3 to time. So do 3, number 5, number 6, and number 7, and then come back. We'll check them, and then we'll do 8, 9, and 10. So right now we're just doing 5, 6, and 7. Here's the first 3. Go ahead and check what you got. Only part I think should be a problem, but might be right here. Just to know that 1/3 could be simplified. So the cube root of 64, the way you'd know that is just checking your calculator. You would just type in the calculator, cube root of 64, enter and see if it's a whole number. You don't have to have that memorized. And then here, just knowing that 1/2 times 2 is 1. Same for here, 3 times 1/3 is 1. So to simplify out. And then here, we use the quotient rule twice. What we're going to do, if you have a negative exponent, use the quotient rule first if you need to, like if it's possible, and that will normally get rid of the negative exponent because you're always going to move towards or subtract towards the bigger number. So the x's, the bigger number is +2, so we subtracted to the bottom. And then for the t's, the bigger number is +9, so we subtracted to the top. And that's how I got here. So 9 minus, and then we had a -9. And then we had 2 minus, and we had a -2. That's how I got here. For these, don't try to do it in your head. You can just type this in the calculator just like that. And then we could divide it out of 5. There we go. Hopefully this is coming easier to you because you remember it. Go ahead and pause, do the rest of the page, and then come back. Is the rest of the page. Number 8 was very quick. You had a negative exponent here. To get that negative exponent turned into positive, it was in the numerator. I knew that because I didn't have a denominator, so it had to be in the numerator, right? If you can see, right, this is a fraction. If something's in the denominator, you can see it because it has to be a fraction, right? This one's not a fraction, so it's in the numerator. So I just moved everything to the denominator. And then it was just now a positive 1. If it's a positive 1, obviously it doesn't change anything. So that gives us this. Number 9, try to write it out into a bunch of steps so it'd be easier for you to follow. I had a floating 2 that's going to multiply by everything on the inside. So I can see that here. There's all my 2's. And then I just simplified that. So 4 times 2 is 8. 2 there. And then -3 times 2 is -6. And then this 7 obviously is being multiplied. So I stuck on the top of the fraction. And then I had a negative exponent. I'm going to move it to the other part of the fraction and make it positive. That gets me to here. And then I realized, hey, I have 2 7's. So I'm just going to subtract those. I have a 7 to the first power, then 7 squared. So I'm going to subtract towards the bottom because that's where the bigger exponent is. 2 minus 1 is 1. So I just wrote it like that. And then last but not least, we have an SAT question. It says, which of the following expressions is equivalent to negative x to the power of 1/4? So I separated the -1 by the x to the 4th right here. And that gets us to here. Now I'm just going to revert this back into a radical, gets me to here. And then if you could probably see from here that it was going to be this one, but I just went ahead and simplified down so you could see it as well. And there we go. Hope this helped. Have a great day. Bye.